Hello children, last classes we had discussed about the biomolecule carbohydrate and we had observed that carbohydrates, it could be divided into three different types, that is monosaccharide, oligosaccharide and polysaccharide. So, oligosaccharides could again be divided into monosaccharide, disaccharide, trisaccharide and tetrasaccharides, isn't it? And polysaccharide included number of monosaccharide molecules together. We had discussed all that, isn't it? Now, today we will discuss the Malicious test. Malicious test, it is a test which is used to identify whether a given substance is carbohydrate or not. So, what is malicious test used for? It is a test which helps us to identify whether the given substance is a carbohydrate or not. Now, when I say carbohydrate, this malicious test is given by all the different type of carbohydrates. That is, monosaccharides are also giving the malicious test, oligosaccharides and even the polysaccharides. Okay. So, this test actually it is used for detection of all the different type of carbohydrate. Now, when I say malicious test, what is this malicious reagent or what is the reagent being used to identify the compound as carbohydrate or not? So, the reagent or malicious reagent, हम जिसे कहते हैं ना, the reagent which you have to add to the compound to identify whether your compound is carbohydrate or not, that is malicious reagent. Okay, malicious reagent, and malicious reagent is 1% alcoholic solution of alpha naphthol. Alpha naphthol. Now, what is alpha naphthol, you will ask me. So, alpha naphthol is this compound. Okay, this is known as alpha naphthol. So, 1% alcoholic solution of alpha naphthol is considered as malicious reagent. So, now what are you supposed to do? See, in a test tube you will take, actually you will be doing this, you were supposed to do it in the laboratory, but because of this situations certain experiments are omitted, so that this is not included. Actually malicious test क्या होता है कि कार्बोहाइड्रेट ले लिया, कोई भी कार्बोहाइड्रेट ले लो, तुम अपना शुगर ले लो या स्टार्च कोई भी, what do? You add the malicious reagent. What is the malicious reagent? 1% alcoholic solution of alpha naphthol. Alpha naphthol का जो solution है alcohol में prepare किया हुआ, that solution you add to the carbohydrate, and to this mixture you are adding slowly concentrated H2SO4 from the walls of the test tube. So, what will happen? After you have added the concentrated H2SO4, you will find a violet colored product forming at the junction of the two solutions. देखो, ये तुम्हारा carbohydrate है. Okay, this is your carbohydrate. Okay, plus 1% alcoholic alpha naphthol. Okay. Or what do you add? Alpha naphthol hai, and to this you are adding, that is walls of the test tube, you are adding concentrated H2SO4. You are adding concentrated H2SO4. Okay? So, what will happen at the junction? Now, you have added H2SO4. At the junction of the two solution, you will find a violet coloration. You will find violet coloration. Okay. So, this is how you can understand the test. Violet coloration अगर आ रहा है मतलब तुम्हारा जो compound है वो carbohydrate है. Okay. So, this is what we call as malicious test. Now, what is the chemistry behind it? You can see. See, all the carbohydrate, whether it is monosaccharide, oligosaccharide, disaccharide, all of them, they will get converted or hydrolyzed into the monosaccharides. The concentrated H2S, in presence of concentrated H2SO4, it will form a compound which we call as furfural, or which is the other compound which may be formed, that is 5-hydroxymethyl furfural. Okay, ये दोनों compound बनता है. अब ये दोनों compound when it is treated with alpha naphthol, this is alpha naphthol, this is 1% alcoholic solution of alpha naphthol. Okay, and this is 5-hydroxymethyl furfural. Okay, 5-hydroxymethyl furfural. Followed or not? अब ये दोनों का mixture in presence of concentrated H2SO4, when you add concentrated H2SO4, it gives violet colored products at the junction of the two solutions. So, at the junction of the two solutions, you will find this violet colored products indicating the presence of molasses, indicating the presence of carbohydrate. Okay, and this is only what we call as molasses test. ठीक है, तो ये note down कर लो. The next point which we are going to discuss is that we had seen the carbohydrates could be divided into non-reducing sugar and reducing sugar. Non-reducing sugar was those which could not reduce reagents like Fehling solution or Tollens solution. ठीक है. Reducing sugars are those which get reduced or which reduces the Tollens reagent or the Fehling solutions. Okay, all the monosaccharides and the disaccharides, all the monosaccharides and disaccharides except sucrose are reducing sugars. Okay, so you can note this down ki all monosaccharides and disaccharide saccharides except sucrose are reducing sugars, ठीक है. तो ये बात याद रखना कि सारे जो मोनोसैकेराइड्स एंड डाइसैकेराइड्स है, they are reducing sugars. That means they will reduce the Fehling solution and the Tollens reagent. ठीक है. Only sucrose will not do that. Okay. So why it doesn't do, we will study when we learn about the sucrose. Okay. So they undergo, देखो, this is your D-glucose. D-glucose will react with the Fehling solution. This is the components of the Fehling solution. Okay, the components of the Fehling solution. Actually, it is a copper sulfate solution only. Okay, so Fehling solution, Fehling A, Fehling B, both are there. This will reduce the, it will reduce the Fehling solution, and you obtain the red precipitates. This is the red precipitates of copper oxide. This also actually you are supposed to do in the laboratory. Again, this thing I think it is not included in this year's practical course. So you understand that whenever we take glucose and add the Fehling solution, Fehling's A, Fehling's B mixture, you will get red colored precipitate indicating that your sugar is reducing. तो मतलब ये जो test है, the Fehling's test and the Tollens test both, it is used to identify whether your sugar is, whether your carbohydrate is reducing or non-reducing. So this is the test to identify whether your carbohydrate is a reducing carbohydrate or non-reducing. ठीक है. अगर तुम starch के साथ if you add Fehling solution, it will not give the red precipitates, indicating that that is a non-reducing sugar. ठीक है। सिमिलरली ये जो टॉलरेंस टेस्ट है, दिस इज एक्चुअली अमोनिकल सिल्वर नाइट्रेट सॉल्यूशन, ओके। सो दिस इज इंडिकेटिंग योर टॉलरेंस रिएजेंट, ठीक है। टॉलरेंस रिएजेंट, when you treat it with glucose, what do you obtain? You obtain a silver mirror being deposited at the walls of your test tube, indicating that this tolerance reagent is reduced to Ag. Here you can see Ag is in the combined form with ammonia, where here Ag is being reduced, this compound is reduced to Ag. तो एक सिल्वर मिरर फॉर्म होता है ऑन द वॉल्स ऑफ योर टेस्ट ट्यूब. सो दैट अगेन इंडिकेट्स दैट योर शुगर इज रिड्यूसिंग शुगर. ठीक है. सो ये दोनों टेस्ट जो है ये हमें इंडिकेट करता है कि योर शुगर इज रिड्यूसिंग शुगर. ठीक है. द थर्ड रिएक्शन इज द रिएक्शन ऑफ अ रिड्यूसिंग शुगर विथ phenyl hydrazine to form the ozazone. Okay, phenyl hydrazine to form the ozazone. Okay. So what is occurring here? See, CHO, okay, COH, H, CHOH thrice, then CH2OH. यही है ना तुम्हारा ग्लूकोज. Okay, this is your glucose. Okay, and now when it is treated with C6H5NH2, this is known as phenyl hydrazine. इसका नाम क्या है? It is phenyl hydrazine. Actually hydrazine is NH2, but here one of the H is replaced by a phenyl group, so it is called as phenyl hydrazine. ठीक है. अब phenyl hydrazine, नो, आई विल जस्ट राइट दिस इन द प्रॉपर मैनर कि ये डबल बॉन्ड O वाले फॉर्म में लिखती है. ठीक है. आर यू फॉलोइंग व्हाई आई एम राइटिंग? ठीक है. सो हियर C डबल बॉन्ड N NH NH C6H5. Okay, then you have C double bond O and CHOH thrice with CH2OH. Are you understanding? So there is a reaction taking place between phenyl hydrazine and the glucose molecule. The second molecule of phenyl hydrazine C6H5NH2. This is second molecule of phenyl hydrazine. It reacts with this compound and it now gives you what you can see, double bond N NH C6H5. Okay. This C double bond I am sorry, here it should be actually COH H. Are you following what happens? This double bond is being double bond O is now converted into double bond C double bond N NH, that is a phenyl hydrazine molecule is added there. ठीक है. ये पार्ट ऐसे ही रहता है in the first step. In the second step this will be getting converted to C double bond O and CHOH thrice and CH2OH. इस तरह से होता है. ठीक है. With the second molecule this process is occurring and there is a removal of C6H5NH2. मतलब इसके साथ aniline molecule is removed. Okay, it will become C6H5NH2. This is removed here. ठीक है. One more molecule of phenyl hydrazine will react C6H5NH NH2. ठीक है, and give you what, HC double bond N NHC6H5, C double bond N NHC6H5, CHOH thrice, CH2OH. So, how many molecules you can see? 3 molecules of phenyl hydrazine is taken per molecule of glucose. And now what you have obtained is the osazone or glucosazone, okay, or you can simply say it as osazone. So, here you observe that for 1 mole of glucose, 3 moles of phenyl hydrazine is used. 3 moles of phenyl hydrazine is being used. So, this is the explanation for the formation of osazone. ठीक है, यहाँ पे first step, 1 molecule is being added to the glucose molecule. Secondly, when you add next molecule, this OH group is oxidized to COO group. The removal of aniline along with NH3 also, okay, NH3 is also being removed here. So, both are being removed here, and everywhere you will find that H2O is removed, okay. Here also H2O is also removed. So, second molecule will convert the OH of the second carbon into ketone group, and here the third molecule will get added up at the second position. So, what do you find here? Ki at carbon 1 and 2 only the changes are taking place. So, any molecule which have same group at the first and the second carbon will give the same osazone. It will give you the same osazone, okay. I am sorry, I have written the glucosone here, but this is your osazone formation, okay. This is your osazone, ठीक है, or you can write it as glucosazone, okay. So, this is how the reaction you can explain for the formation of osazone. Now, we will discuss about the reaction of glucose with a monosaccharide, or rather we are talking about glucose भी हो सकता है या दूसरा कोई भी monosaccharide हो सकता है, monosaccharide का reaction with alkali. Now, glucose, no, when it is treated with, we have taken the example of glucose, that is why I am talking about glucose. Glucose, when you treat it with concentrated alkali solution, what is happening? First it will turn yellow, then it will turn brown, and lastly it will go into a brown resinous mass. You obtain a mass of brown color. ठीक है? This is when you are treating the glucose with concentrated alkali solution. Now, if suppose you are treating your glucose with dilute alkali solution, then what is happening? You get an equilibrium mixture of D-glucose, D-mannose, this is the structure of D-mannose, and D-fructose. So, you get an equilibrium mixture, and this equilibrium mixture exists by a process which we call as 1,2 enolization. This is the enediol you get. You can see here at the first and second carbon the double bond existence is there. Okay. So, through 1,2 enolization you find that the glucose has converted into an equilibrium mixture of D-mannose, D-fructose and glucose. Okay, this is how we can understand the reaction of monosaccharides with alkali. ये जो रिएक्शन है ये अगर तुम फ्रुक्टोज से शुरू करोगे या मैनोज से भी शुरू करोगे तब भी यू विल मैनोज विथ डाइल्यूट alkali solution or d-fructose with alkali solution, dilute alkali solution, you will get an equilibrium mixture of all these three, d-glucose, d-mannose, d-fructose. ठीक है, and this equilibrium mixture is obtained by the formation of this indiol. ठीक है, this may be probably the reason why fructose, even though it does not have an aldehyde group, see here fructose is having a ketone group. So, fructose, even though it does not have an aldehyde group, it gives the test, tolerance test and Felling's test both. Okay, so that may be the reason that this fructose is getting converted into an equilibrium mixture with D-glucose, which is having the aldehyde group, or D-mannose, which is having the aldehyde group. Okay, so these were this reaction. Now it is particularly known as Lowry de Bruyn van Ickenstein rearrangement. Okay, so there is a rearrangement process taking place in this particular reaction. 1,2 enolization is actually meaning a rearrangement occurrence. Okay, so therefore we can observe this with glucose or mannose or fructose when it is treated with dilute alkali solution. Okay, so these were few reactions of the monosaccharides which help us to identify the reducing sugar or not, or the monosaccharide, whether your compound is a monosaccharide, disaccharide or polysaccharide. Okay, so you can note this down. Thank you.